Dear all, this is Dilip Udhani. In the last lecture, we have discussed how to find out the series solution of first order differential equation. In this lecture, I will make you understand how to find out the power series solution of second order differential equation. That is example number 2. Example 2 is find the power series solution of the equation x square plus 1 y double dash plus xy dash minus xy equals to 0 about x0 equals to 0. Here the maximum derivative is 2, so this is second order differential equation. Now first of all, we have to convert this second order differential equation into standard form. To convert this equation into standard form, what we have to do, we have to divide this equation by the coefficient of y double dash. In this equation, the coefficient of y double dash is x square plus 1, so we will divide this equation by x square plus 1. If we will divide this equation by x square plus 1, it will become y double dash plus x over x square plus 1 y dash minus x over x square plus 1 y equals to 0. Now comparing this equation with the standard form, and the standard form is y double dash plus p of x y dash plus q of x y equals to 0. So p of x is x over x square plus 1 and q of x is minus x over x square plus 1. Now if you will put down the value of x equals to 0 in this function, it will become 0 over 1. So p of 0 is 0, and if you will put down the value of 0 in the function of q of x, it will become q of 0, and q of 0 is minus 0 over 0 plus 1. It means again this is 0. So p of x and q of x both are defined at x0 equals to 0. So x0 equals to 0 is an ordinary point. Now let the series solution of the given differential equation about x0 equals to 0 be y equals to summation from n equals to 0 to infinite an x minus x0 the whole raised to n, where x0 is an ordinary point. Here x0 equals to 0 is an ordinary point. Now put the value of x0 equals to 0 in this solution. So the required series solution is y equals to summation from n equals to 0 to infinite an x raised to n. Now what we have to do, we have to differentiate this equation with respect to x. Now derivative of y with respect to x is y dash, and derivative of x raised to n with respect to x is n x raised to n minus 1. So y dash is summation from n equals to 0 to infinite an into n into x raised to n minus 1. Now again differentiate this equation with respect to x. So derivative of y dash is y double dash, and derivative of x raised to n minus 1, the result is n minus 1 into x raised to n minus 2. As y is the solution of given differential equation, then we have to put y dash and y double dash in a given equation. Here the given differential equation is x square plus 1 y double dash plus xy dash minus xy equals to 0. Now x square plus 1 is as it is. This is y double dash, that is summation from n equals to 0 to infinite n minus 1 x raised to n minus 2, plus this x as it is, and this is y dash, and y dash is summation from n equals to 0 to infinite an into n into x raised to n minus 1 minus this x as it is, and this is y, that is summation from n equals to 0 to infinite an x raised to n. Now we have to simplify this equation. For that purpose, what we have to do, now we have to multiply this whole term by x square, and then after this whole term by 1. Now if you will multiply this term by x square, you can see that the power of x is 2, and over here the power of x is n minus 2. So the resultant power of x will be n minus 2 plus 2, that is x raised to n. So x square into this term will become summation from n equals to 0 to infinite an into n minus 1 into x raised to n. Now this plus sign as it is, now multiply 1 by this term, so we will be getting the same term, that is summation from n equals to 0 to infinite an into n minus 1 into x raised to n minus 2. Then after, here you can see that the power of x is n minus 1, and here the power of x is 1. If you multiply x raised to n minus 1 by x raised to 1, the result is x raised to n minus 1 plus 1. So it will become x raised to n, and an into n, that will be as it is. Now we have to multiply x raised to 1 by x raised to n, so it will become x raised to n plus 1. Now you can see that here the power of x is n, here the power of x is n, here the power of x is n minus 2, and here the power of x is n plus 1. So what we have to do, we have to convert all these terms into maximum power of x or minimum power of x. The choice is yours. Here in this equation, the maximum power of x is n plus 1 and the minimum power of x is n minus 2. So we will convert all the three terms, this first, then after this one second, and this one third term, into the power of x, that is n plus 1. Here I have written that the maximum power of x is n plus 1. So we will convert this term, and this term to x raised to n plus 1. To convert this x raised to n into x raised to n plus 1, what we have to do, we have to replace n by n plus 1. Similarly, over here, to make x raised to n minus 2, x raised to n plus 1, we have to replace n by n plus 3. And again over here, we have to replace n by n plus 1 to make it x raised to n plus 1. Now in this term, replace n by n plus 1. So it will become summation from n plus 1 equals to 0 to infinite an plus 1, replacing n by n plus 1, so it will become n plus 1, n by n plus 1, so plus 1 minus 1 will cancel out, so it will become n, and replace n by n plus 1, so it will become x raised to n plus 1. Now in this term we have to replace n by n plus 3, so summation from n plus 3 equals to 0 to infinite an plus 3, replacing n by n plus 3, replacing n by n plus 3, so plus 3 minus 1, it will become n plus 2, and replacing n by n plus 3, so n plus 3 minus 2, the result is n plus 1. Now in this sum we have to replace n by n plus 1, so summation n plus 1 to 0 to infinite, then after an will become an plus 1, n will become n plus 1, and x raised to n will become x raised to n plus 1. Now again over here, this term will be as it is, because it is already in x raised to n plus 1 form, so that is summation from n equals to 0 to infinite an x raised to n plus 1. Now the power of x in each and every term is same, and by doing so the range of n will be different. Here you can see that the range of n is from 0 to infinite, here the range of n is from minus 1 to infinite, here the range of n is from minus 3 to infinite, and here the range of n is from minus 1 to infinite. Now we have to make the same range of n. So for that purpose what we are doing, first of all, in this term we will put down the value of n equals to minus 1. If you will put down the value of n equals to minus 1 in this term, first term will become 0, because minus 1 plus 1, the result is 0. Then after, put down the value of n equals to 0. So here n is 0. So the second term will also become 0. And then after, this term will be as it is and start from n equals to 1 to infinite. Now in this term, put down the value of n equals to minus 3. If you will put down the value of n equals to minus 3, its first term will become 0. Now you have to put down the value of n equals to minus 2. If you will put down the value of n equals to minus 2, so minus 2 plus 2 will become 0. Then after, put down the value of n equals to minus 1. If you will put down the value of n equals to minus 1, an plus 3 will become a2. Minus 1 plus 3, the result is 2. Minus 1 plus 2, the result is 1. And minus 1 plus 1, the result is 0. So it will become x raised to 0. Then after, we have to put down the value of n equals to 0. If we will put down the value of n equals to 0, it will become a3. 0 plus 3, the result is 3. 0 plus 2, the result is 2. And 0 plus 1, the result is 1. So it will become x raised to 1. Now remaining term will be as it is. So we have to write down it as summation from n equals to 1 to infinite, an plus 3, n plus 3, n plus 2 into x raised to n plus 1. Now for this term, you have to put down the value of n equals to minus 1. If you will put down the value of n equals to minus 1, it will become 0. So its first term is 0. Then after, put down the value of n equals to 0. If you put down the value of n equals to 0, an plus 1 will become a1. And x raised to n plus 1 will become x raised to 1. And the remaining term will be in the form of summation n equals to 1 to infinite, an plus 1, n plus 1, x raised to n plus 1. Now this minus sign will as it is, and put down the value of n equals to 0. So it will become a0. And if you will put down the value of n equals to 0 over here, it will become x raised to 1, x raised to 1. Then after, plus the remaining terms will be as it is. So those terms will be summation from n equals to 1 to infinite, an x raised to n plus 1. Now we have to simplify this equation. See, this is the constant term 2a2. All these terms are of terms of x. Now the remaining terms will be as it is. Now in the right hand side we have been given 0, so we will write down 0 as 0 plus 0x plus 0x square plus 0x cube, and finally dash 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 up to 0x raised to n. So comparing constant term to 0, the coefficient of x to 0, and the coefficient of x raised to n plus 1 to 0. So the constant term is 2a2, so 2a2 is 0. So from here we have the value of a2, that is 0. Now this is the coefficient of x. So coefficient of x is 6a3 plus a1 minus a0 equals to 0. And from here, if you will make the subject of a3, so the value of a3 is a0 minus a1 by 6. Now we have to equate the coefficient of x raised to n plus 1 to 0. Here the coefficient of x raised to n plus 1 is an plus 1, n plus 1, n. So we have written an plus 1, n plus 1, n. And then after, the coefficient of x raised to n plus 1 is x raised to n plus 1 is an plus 1, n plus 1. And then after, the coefficient of x raised to n plus 1 is an plus 3, n plus 3, n plus 2, and finally the coefficient of x raised to n plus 1 is an, so minus an equals to 0. So from these two terms we have taken common an plus 1 and n plus 1. So in the bracket we have n plus 1 plus these terms as it is. Now we have to make the subject of an plus 3. If we will make the subject of an plus 3, right, and after simplification we will be having a recurrence relation, that is an plus 3 equals to an minus n plus 1 the whole square into an plus 1 divided by n plus 3 into n plus 2. This recurrence relation is true for n greater than or equals to 1, because in these four terms n will start from 1. So this recurrence relation is true for n greater than or equals to 1. Now with the help of this recurrence relation, With the help of this recurrence relation, we are in the position to find out the values of A4 and A5. If we will put down the value of n equals to 1 over here, the left hand side will become A4, and then the right hand side we have A1 minus, put down the value of n equals to 1, so 1 plus 1 2, 2 square is 4, and the value of n is 1, so 1 plus 1 is 2, so over here we have A2, and divide by 1 plus 3 is 4, 1 plus 2 is 3, A1 as it is, but the value of A2 is 0, so the result is A1 by 12. So the value of A4 is A1 by 12. Now put down the value of n equals to in the recurrence relation, and put down the value of A2 is 0 and A3 is A0 minus A1 by 6, and simplify this result. The value of A5, that is 3 by 40 into bracket A1 minus A0. Now the required series solution is y equals to A0 plus A1x plus A2x square plus A3x cube plus A4x raised to 4 plus A5 x raised to 5 plus dash 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 and so on. Now in this series solution, we have to put down the values of A2, A3, A4 and A5. A0 plus A1x as it is, the value of A2 is 0, the value of A3 is 1 by 6, A0 minus A1 into x cube, the value of A4 is A1 by 12 x raised to 4, plus the value of A5 is 3 by 40, A1 minus A0 x raised to 5 and so on. Now we have to separate the terms of A0 and A1. Over here you can see this is the term of A0, so A0 common, into bracket we have 1, and this is the term of A0, so into bracket we have x cubed by 6, and again this is the term of A0, so into bracket we have minus 3 by 40 x raised to 5. Now this is the term of A1x, so by taking common A1, so into bracket we have x, this is the term of A1, so by taking common A1, into bracket we have minus x cubed by 6, similarly this is x raised to 4 by 12, and finally this is 3 by 40 into x raised to 5. We have separated the terms of A0 and A1. Now you can see that this is a second order differential equation, so your answer will be in terms of two arbitrary constants. One is A0 and A1. If the differential equation is of first order, then your answer will be in terms of A0 only, and if your differential equation is of second order, then your answer will be in terms of A0 and A1. Thank you for watching this video.